Right, yesterday we looked at some angle theorems. Now let's go over the triangle theorems. And of course our first one is the angle sum. And we know the angle sum of any triangle is, of course, 180 degrees. Let's actually now go and prove it using our angle theorems. So if I wanted to use it, that's what I'd say. And as I mentioned yesterday, I'd actually write angle A plus angle B plus angle C, whatever they happen to be, is equal to 180. Okay, so the proof. I'm going to construct a new line, DE, parallel to BC, that passes through the point A. So there we go, there's some parallel lines. So now I can use some parallel line theorems. I can say angle DAB is the same as ABC. They are, of course, alternate angles in our parallel lines. I can also say the same thing for EAC and ACB. They're also alternate. Well, looking at the straight angle DAE, well, DAE could be written another way, and that is, in fact, DAB plus BAC plus CAE. So all of those three are, in fact, a straight angle. So I know they add up to 180. But we've just said DAB is the same as ABC, and EAC is the same as ACB. So if I substitute that in, I get the three angles of the triangle adding up to be 180 degrees. So there's a proof. The other triangle theorem that we often use, although a lot of people forget it, it's the exterior angle theorem. And we know the exterior angle of any triangle will equal the sum of the two opposite interior angles. So for this one, ACD would be the same as angle A plus angle B. Now, a lot of people waste time by doing an angle sum of a triangle and finding angle C, and then doing a straight angle and subtracting it from 180. So taking a couple of steps when really it's just one step, using the exterior angle of the triangle theorem. So let's prove this one. I'm going to construct a line, this time CE parallel to BA. And again, this will create some parallel line theorems that I can use. So ABC and ECD, they'll be corresponding angles on our parallel lines. BAC and ACE are alternate angles. But ACD is in fact the same as ACE plus ECD, just written a different way. So they're common angles. Substituting in what we worked out before, then, okay, so ACD must equal ABC plus BAC. Well, let's take it a step further. They were triangles. Let's add another side, or an infinite number of sides, really. So any polygon. So Polygon theorems, this one, of course, is a quadrilateral. The angle sum of a quadrilateral we know is 360. So A plus B plus angle C plus angle D equal 360. So similar to what I did with the triangle, I would actually write down these four angles add together to give 360 because of the angle sum of ABCD. The proof's quite easy, really. All I need to do is drawing a diagonal, and I've changed the shape now. Instead of being a quadrilateral, I can think of it as two triangles. And I know the angle sum of each of those triangles is 180 degrees. Therefore, the angle sum of the whole shape must be 360 degrees. I could do that for any polygon. So here's a pentagon. The angle sum of this one turns out to be 540. Now, notice this, by the way. When I was using angle sum with triangle, I wrote triangle ABC. But once I get above three sides, I don't need to name the shape. I can just say ABCD. And the reason for that is, again, ambiguity. Because if I just mention three letters, am I talking about a triangle or am I talking about an angle? Could be either. So that's why we write triangle ABC or angle ABC to distinguish between what we're actually talking about. But once we get more than three, then it has to be a polygon I'm talking about. I don't have an angle ABCD, so we don't need to mention the actual shape itself. Same with our pentagon here. The proof, quite similar. This time I'll draw in two diagonals and we chop the shape up. Instead of thinking of it as one pentagon, it's now three triangles. And I know the angle sum of each of those triangles is 180. And so we get an angle sum of 540. Now, that pattern, of course, will happen every time. So we can generalize it to any polygon. Because what would happen is I'd draw in the diagonals and I'd always end up with two less triangles. So the angle sum must be 180 times n minus 2 for the number of triangles. I've chopped the shape into. The other polygon theorem, the exterior angle theorem, is that it doesn't matter how many sides the shape has, the sum of all the exterior ones will always be 360 degrees. I don't think I did a proof, but it's easy enough to prove because we can say, well, I know the interior angle sum is 180 n minus 2. And then I could say, well, each of these exterior ones will be 180 minus the interior one. And I've got n of those. And we end up getting that, oh, okay, so the outside ones must add up to be 360. So A plus C plus D plus E would be 360. Okay, there's our triangle exercises.